Hello mga ka-Johnny! Welcome back to my YouTube channel. Again, this is Sir Robinson, your partner in learning mathematics. But before you begin in this video, do not forget to click the subscribe button and give me a thumbs up if my video helps you. This time, we are going to talk about another type of interest, and that is what you call compound interest. In my previous video, I discussed to you simple interest. And by definition, simple interest, that is a kind of interest usually applied for a very short period of time. Say for example, I borrowed 5,000 pesos for 1 year at 8% interest. That is good for 1 year. An 8% interest rate, that is the increase of the money you borrowed. And that 8% can be filled for the entire year. Now, another type of interest is what you call compound interest. What is the difference when you say compound interest difference from simple interest? Compound interest, this is the type of interest where your money increases as fast compared to simple interest. Say for example, your money is compounded semi-annually. When you talk about semi-annually, that is twice a year. Semi-2, annually 1, meaning twice a year. In short, your money will increase twice a year after every 6 months. Compared to simple interest, the 8% will be fully filled at the end of the year. Now, to understand it more, today we are going to discuss compound interest. To understand compound interest, we have to consider this important characteristic of compound interest, and that is what you call compounding periods. Question: what is compounding period? Compounding period describes to how frequent your money will increase. Say for example, this compound interest at my back. Compounding periods: annually, semi-annually, quarterly, bi-monthly, monthly, and so on and so forth. These are some of the compounding periods that you may encounter as you solve compound interest problem. And this compounding period says to how frequent your money will increase. Say for example, annually. When you talk about annually, it talks about every year. Yes. In short, your money will increase every year, or the full percentage rate or the interest rate will be applied every year. Semi-annually, it talks about every 2 years. In short, every 6 months. Quarterly, that is it will increase 4 times a year, or 3 months, every 3 months. How many 3 months in 1 year? We have 4. Bi-monthly, your money will increase every 2 months. Monthly, your money will increase every month. In short, compounding periods describe to how frequent your money will increase every year. So these are some. Take note, as you can observe, these are some. Meaning, we have lots of compounding periods and compound interest problem. How are we going to identify the compounding periods in a compound interest problem? Simple. You observe to the problem, where is the adverb of frequency, or those words that ends with ly. And once you identify that one, automatically, those adverb of frequency in a problem is the compounding periods. That's how easy you identify that one. So now, we are done defining compounding periods. This time, let's convert this following into numerical value. Now, if you encounter annually, meaning your money will increase 1, that is equivalent to 1. 1 means it increased once a year. When you encounter semi-annually, it talks about 2, meaning it increased twice a year. When it talks about quarterly, it talks about 4, meaning your money will increase 4 times a year. When you talk about bi-monthly, it talks about 6. Why 6? Because bi-monthly will increase every 2 months. How many 2 months in 1 year? We have 6. Monthly, it talks about 12 because we have 12 different months in 1 year. So these are the numerical equivalent of our compounding periods. Annually 1, semi-annually 2, quarterly 4, bi-monthly 6, and monthly 12. This will help you identify later on how to solve compound interest problem. So, we are done identifying all this important characteristic. And I believe every one of you is ready now to solve. We already understand the characteristic of compound interest. This time, let's try to see the formula on how are we going to solve compound interest. This is the formula of compound interest. Let's define each one. M here, that is the maturity value. In short, if you deposited, borrowed, or invested money plus the interest of that amount, that is the maturity value. P here, that is your principal. What is a principal amount again? Principal amount, that is the amount you borrowed, you deposited, or you invested. 1 here is constant. R here is what you call the rate of interest. Whatever in the percentage form, automatically, that is your rate. M here is what you call the compounding period. In short, to how frequent your money will increase in a year. That is your M. Example, annually, semi-annually, and so on and so forth. T here, that is the time. To how long your money will increase. T, same with simple interest, that is always in years. So this is the formula for compound interest. Now, let's try to solve problems involving this formula. I already defined to you the compounded periods, at the same time, the formula and compound interest. This time, let's try to solve problems involving compound interest. For example, number 1, let's find the compound amount and the amount of interest. When I say compound amount, I am referring to the maturity value, or what is the total amount that I am going to receive or pay when I borrowed money. The amount of interest, that is the additional in the principal amount that you deposited, borrowed, or invested. In this problem, let's find the two important elements. Considering that 10,000, I borrowed 10,000 for 5 years at 6% compounded annually. This is my problem. But before that, let's identify the important elements that we need to in order to solve the problem. Take note that the formula is M is equal to P 1 plus R over M raised to the power of MT. Do we have P here or the principal amount? Yes, we have 10,000. Therefore, P here is 10,000. Do we have R in this formula? Yes. R here is 6% or the rate. How about the M? Do we have the M? Yes. Compounded annually or our compounding periods to how frequent our money will increase. That is compounded annually. Again, when you talk about annually, it increases every year. So what is the numerical value? The numerical value for annually is 1 because your money will increase once a year. Do we have a time in the problem? Yes, we have 5 years. And since our time is already in years, we don't have a need to convert that one. Now, we already have the PRMT. Are we ready to solve the problem? Yes, we are ready to solve the problem because we already got the important elements. So let's try to solve that one. That is M. What is the value of your P? The value of your P is 10,000. Copy 1. 1 here is a constant element. Plus, what is your R? Your R here is 6%. Same thing. If that is in percentage form, convert that one into decimal. And 6% is equivalent to 0.06 all over M. What is your M? M here is 1. Again, why 1? Because our compounding period is annually. It means it increases once a year. Raised to the power of M. What is again your M? That is 1. Multiply to T. What is your T? That is 5 years. So after that one, after you substitute that one in your formula, you are now ready to find the maturity value. So how are you going to do that one? You simply solve that one, okay? So this is 10,000, I'm sorry. So this is 10,000. 0.06 divided by 1, that is still 0.06. Plus 1, that is 1.06. Raised to the power of 1 times 5, that is 5. Okay, while you are solving this problem, you have a need a calculator in solving that one because it will really help you solve the problem. Okay, so now let's try to look at this one. So you use your calculator. I do hope that while solving this problem, you have a calculator beside you. So that is 1.06 raised to the power of 5. Then you have to multiply to 10,000. What is the answer? That is, where I should write this one. Wait, I'll get my eraser. Okay, so let's try to write it here. That is, the answer for this one is 13,382. Let's round it off to the nearest hundreds. That is 0.26. Therefore, what is 13,382.26? 13,382.26 is the maturity value. It means from borrowing 10,000, you have to pay that amount. Meaning, the interest amount is already there. 13,382 is your compound amount. The question is, what is the compound interest? Let's identify the amount of interest owed from 10,000. Again, this is the compound amount. How are you going to identify the interest owed? Take note, in order for you to identify the interest owed, you have to subtract maturity value minus the principal amount. What is my maturity value? My maturity value here is 13,382.26. Deduct it to, wait for a while, erase this one. I'll deduct 13,000 to, what is my P or my principal amount? That is 10,000 pesos. And once you deduct that one, that is 3,382.26. Therefore, from borrowing 10,000, it adds 3,382.26 as an amount of interest. That's how you solve compound interest, ladies and gentlemen. Again, you use the formula. What are the steps in solving that one? You identify the important elements. Next, you substitute in the formula and you simplify that one. After simplifying, you can get the compound amount or the maturity value. In order for you to identify the amount of interest owed to the money you borrowed, invested, or deposited, you have to deduct maturity value to principal amount. And from that, what we get is 3,382.26. 3,382.26 is the amount of interest owed from borrowing 10,000 pesos. And the total amount that we have to pay is 13,382.26. Easy, right? That's how we solve compound interest. To understand it more, let's proceed to another example. Let's solve more examples to master compound interest. This is example number 2. So example number 2, same thing. Our goal is to identify the compound amount, at the same time, the amount of interest. Again, compound amount means the total amount that you have to pay or you're going to receive as you deposited or borrowed money. So I have here 15,250 for 4 years and 6 months at 8% compounded semi-annually. And obviously, the problem is compound interest because we are dealing with adverb of frequency or what we call compounding periods. Again, how are we going to identify or solve this kind of problem? You have to identify what is asked, and we already know that one. Second is, you have to identify the important elements in solving compound interest. And let's identify, again, the formula is M. M is equal to P or principal 1 plus R over M raised to the power of MT. What is your P or the principal amount here? The P here or the principal amount here is 15,250. You substitute that one in the formula. 1 is constant plus, what is your R or the rate? That is 8%. Or convert it to decimal. That is 0.08. All over M. What is M again? M is the compounding period. Our compounding period here is semi-annually. When we say semi-annually, your money will increase twice a year or every 6 months. Therefore, your M here is 2. Again, why 2? Because that is semi-annually or it increased twice a year. So that is now 2. What is your M here? Again, 2. What is your time? Your time here, as you can observe, is 4 years and 6 months. We have another 6 months here. What are you going to do is to convert this one into years. Simple. You copy the year. You write the 6 months as a numerator and you divide it 1 by 12. Same thing that we did in simple interest. Once we have a months as a time, you have to convert that one into years by dividing over 12 because we have 12 years in 1 month. So this is now 4, 6 over 12. Now, after you substitute in the formula, what are you going to do is to simplify the problem. For you to simplify it even more, you use your calculator. Okay? The first thing that you have to do in order to solve this problem is you have to identify it here. You solve whatever inside this function. So that is, you first input this one, 0.08 divided by 2 plus 1. That is 1.04. That's right. That is, copy 15,250. What is the result inside? That is 1.04 raised to the power of this one. You try to simplify this one. So, that is 2. This is now, you multiply 12 by 4, 12 times 4, and plus 6. That is 54 over 12. Meaning, this one is equivalent to 54 over 12, or that is 2 times 54 over 12. Where did I get? And you multiply that one. 2 times 54 over 12, that is 2 times 54 divided by 12, that is 9. Therefore, the power is 9. Where did I get 9? By simplifying my power. So I have here 15,000, copy the principal amount, 1.04, and 9. Now, after you simplify everything, it looks like this. And after that one, you have to simplify this one, this part. Take note that you cannot multiply 15,000 to 1.04 because we still have a power. Exponent first before multiplying. Therefore, that is 1.04 raised to the power of 9. And you multiply the result to 15,250. In short, we have here 21,705.51. This is now our compound amount. In layman's term, compound amount, that is the total that you have to pay if you borrowed money, or amount that you receive if you deposited money. That is 21,000. But wait, we are not done yet because we have two goals here, is to identify compound amount, check, and amount of interest. How are we going to identify the amount of interest? Simply deduct the maturity value or the compound amount to our principal amount. Let me show you how. Let's erase this part. Okay, let's identify the amount added to the money that we borrowed or deposited. That is the interest. Interest can be get from the maturity value minus the principal amount. What is my maturity value here? The maturity value here is 21,705.51 minus 15,250 because that is my principal amount. Let's try to deduct that one. Minus 15,250, meaning that is 6,455.51. In short, 6,455.51 is the amount of interest added to the money that I borrowed, 15,250, for me to pay 21,705.51 as the compound interest or the maturity value. That's how the compound interest works. The new thing is that, the new thing in compound interest is the compounding periods. And at the same time, same thing. The time in compound interest should be in years. If you encounter this kind of problem, 4 years and 6 months, you have to divide 6 months by 12. Same thing with simple interest. If you have days in the problem, you convert that one by dividing 366. 366 days for the whole year, or 365 if non-leap year. That's how simple compound interest works. I do hope you understand that one. Then after you watch this video, you try to answer the questions anchored to it. Thank you so much, and that ends my video for compound interest. If you still have hard time in understanding how compound interest works, you may replay the video and try to listen it slowly. Remember, you can learn as many knowledge in learning it slowly. Learning is not a competition, so replay the video. Thank you for watching. Again, I am Sir Robinson Ipulan, your partner in learning mathematics. This is compound interest. But before you end this video, do not forget to click the subscribe button and give me a thumbs up if my video helps you. See you in the next video. Bye-bye!